Let's do it. Let's get through this last situation. We have a spring that pushes a cart that expands back to its natural length. The force exerted by the spring depends on the spring's stretch as shown in the graph. First things first, the slope of this graph, let me get out of the way here. We have force versus meters. F over m, that is the spring constant. So if we take our y-axis and we divide it by our x-axis, then that's going to give us something, right? A force per meter when there's a spring involved will be our spring constant. The slope of a spring force versus spring stretch graph is spring constant. This is because F equals kx, which can be written as k equals F over x. The division indicates that the slope of F versus x is k. Remember, whenever you have a graph, first things first, look at the axis, and then what happens if you divide these two? That's your slope. What happens if you take the area under, or what happens if you multiply these two quantities? That would be your area. A force times a meter. What is that? We would say that would be work, right? So this spring constant is k equals 500 Newton meters because that's the slope of the graph. Check for yourself. This is 250, 200, 150, 150. How much work does the spring do as the spring expands from being compressed? 0.4 meters to its natural length. Zero compression. Work is found by taking the area. I just said that. Multiply these two. At least multiply the two units. Newton times a meter. So that way you can see what are these two quantities. And multiplication implies taking an area. Length times width. For this graph, the area is 40 joules, so the spring loses 40 joules of potential energy and the cart gains 40 joules of kinetic energy. So let's say we take away the numbers on the graph. How would we calculate the work done by a spring as it expands back to its natural length? The base of the triangle, x, is the initial stretch of the spring. The height of the triangle is the force, which is k times x. So the area, 1/2 base times height, equals 1/2 x times kx. Are you ready? Are you ready? Boom! This is just 1/2 kx squared, which is the same thing as potential energy of the spring. Work energy theorem. Work is the change in energy, change in potential energy, so you could connect the two. So the work done by the spring is the same as the potential energy the spring loses. What you just saw, gravity is a conservative force because gravity force is associated by potential energy, the gravitational potential energy. The work done by the gravity force